This conference will now be recorded.
Okay, so good evening, Padmini, and welcome back to a professional session on market risk modeling. And we are talking about time series model development. So while we are talking about time series model development, one of the questions which we had answered in the last session was we tried understanding that how is it that we would know by looking at the data that whether we can fit a time series to the model or not, to the data or not. Now, if we cannot do that, so how is that we can fit that into the data? Or so how do we know that we can actually use time series in the model development exercise? If we know that, then the next question that comes out over here is that the next question that comes out over here is that okay, if we know that how we can assess time series model, how we can fit, that we know that we can fit a time series to the data, then the next step is to understand how we can analyze the performance of the how we can analyze the stationarity of that time series data. Now, if we look into the stationarity and we see that the time series is a non-stationary process, the next question that comes out over here is how is it we can use this to develop or to make the station. So how is it that we can reconcile the results and ensure that actually the the conclusion of non-stationarity that we are drawing is a correct analysis, and then how is it that we would go about and develop other so how is that we would go and develop processes which can help us solve this problem of non-stationarity. And once we have done that, the next question comes, what comes out to us is the following: that once the stationarity is sorted, the problem with stationarity is sorted, how do we go about developing the model? So how do we go about estimating the parameters and validating the typical model? So these are some of the questions that we are going to address, that we are going to answer in the next step, in the next part. Right. Okay. So let's start off by assigning the library. So we have assigned the library, and this library will be called the TS library for our reference. Okay. So the data set that we are using is the typical box Jenkins Airlines data, because the reason that we are using it, because even though it's not a financial data set per se, but this data set will have all the ingredients for developing or for testing all the characteristics of the stationarity of a time series, because these are the typical data which they had used to identify or to develop this entire framework. So all those characteristics which is there in the typical autoregressive integrated moving average models, the ARIMA models, which has been developed by Box and Jenkins. So we will be able to look into them in details. So over here we have prop contents data. So we are just first listing down the contents of the data, right? So we did that in the last class, and what we saw was that there were around 144 observations and two variables. So okay, so the raw data set that we had two variables. One was the date variable, and the other was the passenger variable. So basically, the date variable is the time dimension, and the passenger variable is the target variable. So that is the variable which we are going to use to predict or to develop the models. Now, what we are going to do is we are just going to look into the first 5 observations of the data set. The idea just being that we are looking into the first 5 observations so that we can frame an idea about the overall behavior of the data. So how the data actually looks like. So these are the so this is basically the the first 5 records. So now over here we have this data set called time series airlines, right? And in this time series airlines, which is the raw data, right? So from there we created another new data where we had isolated three time point variables, one being the month variable, the other being the year, and the third being the quarter variable. So these are the three set of variables that we have looped in, right? So we had the month, year, and the quarter. So so let's have a quick look into how this data set would look like. So we had this airline data over here. So one thing that you could clearly see is that we had removed the so we had created three time factors from there, right? So that as the need, maybe we could kind of create certain time parameters or certain variables which would help us analyze overall behavior at different levels, right? So over here with the Times Airlines data, right, we can, so we look into the Times Airlines data whether all the variables have been correctly created. So very quickly we'll run this code over here. Yes, we can see that this data set now contains the date, passengers, month, year, and the quarter. So now over here we have the proc print data. So we had the observed data set, the passengers, year, quarter, and also we have all the data sets created, all the variables created in this data set. So over here, what we have is we have so the next question that we tried addressing in the last class was that should a time series model be incorporated? Can a time series model be developed in this case? So over here to so whenever we are trying to develop an ARIMA model, so ARIMA procedure, proc ARIMA is the procedure which is used for analyzing the time series for developing any ARIMA models. So proc ARIMA over here is the ARIMA procedure. The ARIMA procedure is used to generate different measures corresponding to the time series models. Right, the output will be containing of several reports which can capture stationarity of the model as well as summarize the key model results, right? So that is something that we have over there. Now the next question which comes out over here is we have the bar. So the data set is obviously the data which is the reference data set. So the data set on which the model is to be developed. Now, right at the beginning, even before we develop this, there are two questions that we need to address. Number one, we need to look into the overall descriptive measures of this time series. And the second thing that we need to look into is that whether we can develop a time series model on that. So for that, what we do is we look into the last, so we look into up to some like last 8 lakhs, 10 lakhs, something like that. And we try to understand that whether the historical lags have significant correlation amongst themselves or not. Because if the historical lags do not have a significant correlation among them, then they cannot, so then there cannot be a time series model which is there. So over here, so the first step is to understand whether there exists a significant correlation among the history among the last 8 historical lags. Right. So if I look into the SAS, into this code, you will see that that there's proc arima, which is data, airlines data. Then it is identify. Now, what does this identify statement do? This statement is used to generate the descriptive measures for the time series variable. So the basic descriptive measures. So how does that, which is the table that this measure generates? So this statement identifies, generates this particular table, right? The mean of the series, the standard deviation, and the number of the series, right? So it will give you an idea about the extent to which that series can span generally. So the mu plus minus 3 sigma will be that limit, right? Between which I can actually consider the distribution. Now, if it is outside that limit, then those are shear short outlier values. Okay. Okay. Yeah, so I have the variable passengers. No, yeah. So as I was saying, so this identify statement generates this basic descriptive measure. Now with this, the var statement over here specifies that variable for which the time series model is to be developed. And in lag is the number of lags up to which I want to look into the autocorrelation. So over here you can see that there are 8 lags up to which it has been done. Now, the question that comes out over here is that I can see that the lags are gradually declining, right? So as you move across in the historical past, you can see that the lags are going back, and so that the lags are so that the lags have some substantial amount of correlations between them. So the correlation between the Tth period and one period back is 94%. So similarly, between the first 0th and the second lag, it is 87%. So one thing you can see is that as it is going back, the lags are gradually decreasing, but it is decreasing very slowly. So it shows that, which in turn which also gives us an idea that yes, the way that the variable is constructed is not only something which is not only that the lags are significant or the lags are high, but the correlations are gradually decaying. They're not decaying very fast. So there is always a possibility that there is some factor, right? Some temporary factor which is not allowing it to decay very fast. Hence, even though I can see that the correlations are declining, but the standard error is increasing, or the two standard error is increasing, which shows that yes, there are certain factors which is causing that fluctuation to increase, right? So there are some temporary factors which are involved into this ACF pattern. So from here, the next question that comes out is that are these lags significantly correlated? So that report is shared at the end, the autocorrelation check for the white noise. So are these lags white noises? So are they identically independently distributed? Now this check, this chi-square test, right? The autocorrelation check for white noise is that test which tries to answer this question. So it says that it looks into the last 6 lakhs, and it says, and it generates the, because it's a categorical variable, or because the autocorrelation. So when you're looking into the autocorrelation, you're looking into a set of correlation. You're looking at a test of association. Therefore, the statistic, that is the distribution that the test statistic would follow, will be a chi-square distribution. Now, the most important decision is taken by the p-value. So what is the autocorrelation, the null hypothesis and the alternate hypothesis that we are trying to explain over here? What we are trying to explain over here is, the null hypothesis is that the autocorrelation coefficients are identically independently distributed, that is, they are a white noise, versus the alternate hypothesis that the autocorrelations are not a white noise. So that is the relationship between the, right? So if the p-value is less than 0.0001, so if the PL is negligible, so what we are trying to say is that, hey, look, even though I can see that I can see the correlations are there, these correlations are statistically significant, which means that these lags are not identically independently distributed. The extent of autocorrelation is very high among these. That is the reason why we would expect this, so this is the reason why we would expect the autocorrelation check for the white noise. So we would expect that this model or this data can be modeled using a time series, because the historical lags are correlated enough, so they have sufficient correlation to explain the historical lag. Right? So this is something that we would like to talk about. Is this part clear? So this part justifies that yes, a time series model can be developed. So any questions up to this? Perfect. So now from here, what we'll next do is we now need to understand whether the time series is stationary. Right. So the details of this test is documented over here. Now what we'll start off by doing is we'll first try to understand, right, that whether the time series has any component. So first, before we go into the statistical tests of non-stationarity, we are going to try out some intuitive tests, which we are going to try out some intuitive way of identifying whether there can be some, so whether there can be some temporary components. Now, if there are these temporary components, then what we are going to do is we are going to say, fine, then this time series is non-stationary. Right. So we are going to look into those. Okay. So first we'll set out. We'll do a setup. We'll do checks. So first of all, we'll look into the mean values, right? On a year-on-year basis, we look into the average values of the passengers. Now, my objective is to understand that does this value follow any specific trend? So basically, let's say if I see that the values increase at a point time and then they again go down. So I know that over the time period, over the years, there has been a trend, right? So this is something that we need to understand, that is there a long run trend which can be observed in the in the airlines data. So that is something that we'll first start off our analysis. Okay, so what I'm trying to do over here is I'm trying to use the means procedure, and I am trying to generate the mean of the passengers corresponding to each year. The mean which was generated using the in the first statement, is the identify statement, was on the whole data set. Now, what I am trying to do is I am trying to understand this behavior at a monthly level. Right? So if I go back, so the result I am summarizing over here is in this airlines means summary data. So over here, what you will see, so this is the first mean. So this is the overall mean which has been given, or which we had reached. So this is the number of passengers over here, right? So this is the overall mean, and this is the mean which was reported by the uh, other variables, so which was reported by the identify statement. Now what we have done is we have taken this at a yearly level. So in order to do a serious, in order to do a plot, what we'll do over here is we'll just generate this as a data set. As a The ts dot airline means summary run. So very quickly, what we'll do is we will just run this. So now if you have a look into this mean, I mean, if you have a look into this, to the mean values of this time series, you will see that it's a constantly upward rising positive mean. So the mean, so there is a clear positive linear trend in the mean of this time series. Right. So one of the observations that we have over here is this time series, the airlines data displays a linear trend in the mean of the time series. The time series data of the facet. So this means so this identity this shows that one of the components of the of non-stationarity is present in the time. Okay. So one of the things that we can clearly see in this data is so this is the advantage. So the last class you were asking me, Padmini, that why is it that we are breaking it down into month and the the years and the quarters. So if I aggregate the data at different levels and I look into its average behavior over certain periods of time, I'll be able to identify certain underlying characteristics of that data generating process. So like through this mean analysis, so when I look into this long run trend of the mean over a period of time, what I could clearly identify is that, hey, look, there is a uh, so there is a positive upward rising trend. There is a positive upward rising trend in the data sets. So this is something that we have already seen. Right. So so is this interpretation of the data set clear to us? So any questions up to this point for me? So so in this exercise, what I'm doing is I'm just kind of just refining that data set over here. Right. So now, so this is how the series looks like. So I have rounded off to two places of a decimal, and now when I plot it, I'll get a clear cut trend. So this is one of the things that we can clearly see, and I can, so the plot that I did it in Excel, I can also do it in SAS, right? So in SAS we can do this using the Gplot. So now nowadays with the more newer versions of SAS, you have SGplot. So this is Gplot. So this is used to generate graphs between two continuous variables. So over here, even though I have not joined it by the lines, so I'll show you how to join it by the lines. This is the default uh, Gplot graph. So you can see a clear upward rising positive trend in this exercise as well. So, so now the question that comes out over here is, so I can see a linear long run trend in the monthly data. Now, will I observe a similar result over here? Will I observe a similar result in terms of this quarter indicator and everything? So how does that part work out, right? So this is the now. So now what I'm doing is I'm taking my analysis one more step, one more level of granularity. I'm just increasing that. Now I am looking at it at the quarterly level. So now if there are 12 months, for each of the year there will be 4 quarters, right? So I'll get, so in for I'll get around 48 50 records, and I look into it that at each quarter of the year, how has it changed? So can I observe more volatility in the movements when I look at the quarterly level? So at the long run, monthly level, I get a trend, right? So now I increase the granularity and I look at it at the quarterly level. Then if required, I look at it at the daily level. So that gives me an idea about the granularity of the modeling exercise, right? So this is something that we want to look at. Okay. So now what we are going to do is we are going to create out a quarterly level indicator. Right? Now, how do I create the quarterly level indicator? So what I say is that for the year, I concatenate a 0 and the quarter. So basically, if it's 1949 first quarter, it becomes 1949 01, 1949 02, 1949 03, and 1949 04. So how does that data look like? So let's look into this airlines seasonal data. Right now, I am looking at the quarterly level. Right now, if you want to understand, so the long run trend gave me an idea that okay, there is a trend there. Now, if I want to identify a seasonality or a cyclicality, then I only by looking at the yearly level will not give me any result. Right? So what I'm doing now is I'm breaking it down into one level down, and I'm looking at it at the quarterly level, right? So till now you will see that in order to identify each of these components, I have not used any statistical tests. So this is what I'm trying to do through the intuitive analysis. Then I'll do the plots, the ranks and the plot. I mean, I'll do the ACF, PSCF plots. So from there, the result that I will get and this result that I'll be obtaining from this analysis, they must reconcile at PO. So that's what I am trying to do over. Right. So let's have a quick look. Okay. So if I go to this airline seasonal data, so you will see that a new variable called quarterly indicator has been created, and we have looked at it across the quarterly indicators. Okay, one more thing, the plot statement is used to generate the plots, the points between the x-axis and the y-axis. Okay, so let's have a look into this. So similarly, what we are doing over here again is by the quarterly indicators, we are generating the measures, right? That's very similar to what we had done at the monthly level, right? And then what we do, we look at the average. So now to assess, look at the seasonality, I have for each of the quarters, I have the average figures, right? So like we had done for the previous one, we had done the same plots as well over here. Well, so now what I'll do is I'll take this seasonal summary and I will run it. So what you do is you put it over here. Now this is the reason why we had looked into the quarterly figures. You will see that not only there is a trend in the mean, right? There is not only a trend in the mean, but the variances are also varying around the mean. So if I plot, now let's say I plot a trend line to this, I plot a linear, because the mean, the long run mean was a linear line, right? It was a linear one. So what I'll do is I'll put the linear graph over here. So one thing that you can see is that this straight line, that straight line mean that I can see over here is having this equation. So if I fit it, I'll get this equation. And the R square is 88%. So it is not a proper full line fit, right? So it's not a 99 point or 95% fit, it's an 88% fit. Why? Because the variances, now if you see the overall variances across this point, right? So if you compute the variances across this linear mean, what you will see is, so very simply what you get to see is that the variances are varying about the mean. So this time series is not only non-stationary in terms of mean, but it is also variance non-stationary. So look at the dispersion in this region, in this part of the time series, and look at the variance at this part of the time series. So you will see that the variances across these two parts of the time series is very different, and it has actually changed from one point to another. So what does this actually show us? That there exists a, so there exists some temporary factors which is causing the mean to, or the variance to fluctuate about the mean. So what it means is that there is something over here which was not present here. So as a whole, that factor is a temporary factor, and I cannot use that factor in developing the model. So that factor has to be removed from the analysis, and that is what is, and so that is exactly what is caused by seasonality. So there, or it is, so there is some temporary factor. So there is a combination of trend and seasonality in this data. So there's a long run trend, and you can see that the mean is not flat line, it's a upward sloping line. That's one. The second is, you can see that the variances at this part is something lower than the variances over here. So what it also means is that this variation is also very different at 2 points of the story. So at 2 points of this graph. So this vis-a-vis implies that there is a temporary factor in this data, and hence this time series is a non-stationary time series. So I can actually make out that because it's a monthly data, if I'm looking at the monthly data, so what I can clearly make out is that, or even looking at the quarterly level, what I can clearly make out is that there are some regions, right? So there are some time points which is higher and lower and higher and lower, and that continues. So there is an element of seasonality involved into this, right, at a monthly level. And because it's an airlines factor, so it's an airlines data, we expect a seasonality into this, because the winters and the summers, so this is the holiday seasons, and hence the fares will be higher. The passengers will be higher during these, and whereas the off season, the airlines passengers will be much lower. So given this, this problem is something that we need to take care. Right, so this is how I can clearly see in this data that yes, there is a, so there is an element non-stationarity, and a part of it is a linear upward rising trend. So once I detrend the series, the remaining factor that leads back is seasonality, which I need to solve. So that seasonality can be an additive seasonality, or that can be a multivariate seasonality. Right, so we now need to, then we need to look into the patterns of the movement of the air prices. So whether it is increasing by some given multiple, every specific multiple every 12 months, or is it an additive increase in frequency. So from that perspective, we can make out whether the seasonality is multiplicative or additive, and then we need to remove it by that factor and seasonalize that time series as well. Right. So now from here we have seen that yes, it is a non-stationary time series. So if I do the augmented equivalent test and I look into the ACF and the PACF at a monthly level, I should also get the same result. Right. Then I'll say that the conclusions in my time series are reconciling. Clear? Okay. So now I can do that same plot over here as well, and you will see the same thing. So over here, if you plot this, you will see that it is increasing at an increasing rate. So the variances are changing very quickly. Right. Okay. Padme, so just let this, I think my screen is hung up for some of reasons. Okay. Okay, so just let me restart this part. Okay, so we had plotted till the seasonality summary, and what we saw was that yes, there was a linear trend in this, and there is also an element of seasonality incorporated, and hence this time series is non-stationary. Right. So this is something that we have already seen. Now the question is that before I go on to detrend the time series, I need to check whether the same result is coming out through the ACF and the PACF plots, right? So what I'll do is I will take the proc arima statement and I will put it over here. Okay. So now let us have a look into the results that is generated by the autocorrelation and the partial autocorrelation plots. So let us review the results generated by the autocorrelation and the partial autocorrelation. So first of all, what we look into is the autocorrelation. Okay. So let's have a look into the autocorrelation plot first. Now, over here, first of all, we are starting off with the lag at 0. So what is the correlation of the 0th lag with the 0th lag? It is by default 1, right? Now, if as I move 1 lag down, so the correlation with 1 lag 1 is 0.94. And then what you see is that it is gradually declining, right? The lag gradually declines till the ninth or the till the 8th or the ninth lag, right? So with the 8th till the 8th lag, there is a declining feature. But from the ninth lag onwards, right? The ninth lag onwards, you again see that it is increasing, and the so one thing you can see is that with the fourth lag, the this or correlation was 0.75. So it again more or less comes back to that same lag over here. I mean, sorry, at the 12th lag, right? So at the 12th lag again, this it comes back to that, right? So now if I go from the 12th lag, if I again go back to the 24th lag, now from there what you see is that this correlation is again kind of going down, right? More or less it goes down again. But after it reaches the 21st lag, so that's between 12 to 21st, right? 12 to 21st. And observe that between the fourth and the 12th lag, there was 9 lags, right? So there were 9 separate lags, fourth to 12th. So that's 3 to 12, there were 9 lags. From 12 to 21, there are 9 lags. So after every ninth lag, the autocorrelation function is gradually increasing. So it shows that there is a periodic behavior in this time series, right? So in this time series, after every ninth lag, eighth or ninth lag, right, after every 9 months, this is spiking up. So if you think about it, there it is an airlines data, right? And in this airlines data, so every time it should not be, you should not expect it to happen in 12 months. Now, Now, if you think about it, let's say the month of March and April, right? So month of March and April is the summers that are that's there. So you have the summer holidays and summer vacations and stuff like that, and that's when people that's the time when people go to holidays. And then again you have it like 9 months down the line when you have it in the winters, and again that changes. So every 9 lags, so every 9 lags, so twice in a year, you will actually at every ninth lag, you'll actually expect a spike in the range. So from March to December, right? So then again December gone by, then again during the October to December time, and then again you'll expect it to happen in the next 9 months. So more or less, so every 9 months there is some change, right? So the seasonal change, and get to see a spike happening every 9 months in this data. So it shows that this data set has characteristics of seasonality involved in here. So there are seasonal patterns to this data, right? And we've also seen that there is a linearity of the trend. So the result which is shown by these, so by the ACF graph, by the ACF plot, and the results which we had obtained using our intuitive analysis reconciles together, right? And we can clearly say that yes, this data set is a non-stationary data, right? So is this part clear to us now? So we had talked about that seasonality at a theoretical level. Now we are seeing how is it identified in the data, and I'm exploring both the methods because it often happens that when the results come in, we are unable to interpret that. So if we have that intuitive analysis along with us, we should always be able to capture that. So we can always, we can always try to uh, reconcile both the results, right? And that will help us in validation as well. So this is the reason why we are looking into this analysis from both the sides. I have still not talked about the ADF test. I'll talk about ADF a little later because that's quite a complicated test. But if I look into this analysis, we can clearly see how this is. So whether this trend is there or not. So the autocorrelation plots, the ACF plots show that the autocorrelation between the lags, correlation with the current lag, the current time period, spikes up every 9 months. Since this is airlines data, it is intuitive that there will be more than one holiday season in a calendar year. In a calendar year, when the model, when the demand for the airline services will increase. Hence, the periodicity of the data is less than 10. Right. So one of the things is the conclusion over here is the ACF plots also show that the time series is non-stationary. the observations that we had from the intuitive analysis, the observations that we had from the intuitive analysis and the results that we obtained from the model are from the ACFT frequency. Hence, we can safely conclude that the time series is model is stationary. So hence we can conclude that the time series model is stationary. Right. Now the next question is that how do we detrend the time series? So first, what we are doing is we are trying to address that. Okay, look, we are going to identify whether the time series is stationary. So once it is identified, the next thing that we do is we now need to destationarize it. I mean, need to remove those components which is creating it to be non-stationary. We need to stationarize the time series. So over here, we'll also follow one of the an intuitive approach, and then we'll validate it using the ADF test. Because if I'm able to remove these components from the time series data, right, through an intuitive approach, and then if I apply ADF test on it, that ADF test will show me that the time series is stationary. Now, after the transformation has done, so I would know that the detrending and the deseasonalization has been correctly done. So that is the next step, right? So let's catch up tomorrow on this. So let's not do it today, right? So tomorrow we'll meet at around 11:30 in the morning, and then we'll complete this part. Thank you. And in the meantime, you can download the recording from the platform. Thanks a lot.